right, let's get started. So last time we technically finished module 9. However, I'm going to spend a little bit more time today to just tie up loose ends. The loose ends that we had were a few of the methods that I asked you to actually work on between last time and this time. So I'm going to go over them, make sure everybody is on the same page regarding those methods. And then we should be able to start module 10. Before we jump into that, quick announcement. The course official USF evaluations are normally already available. Okay, so I'm going to remind you of that probably this lecture, the next lecture. We might take some time next lecture so that you can actually do the evaluation in class while I'm out of the classroom. Bottom line, this is very important stuff. Okay, so you know already from the previous survey that I did just to try to fix the GCQs, cooperative GQs, that it's not only just a numerical feedback that matter. The numerical feedback, yeah, you are going to have 8 criterion. These are important to help us assess that there is a problem here, and here things seem to be working. But the why is what can turn into action items, right? If I understand why something is working or why it's not working, then I can do something about it. The second thing I want to say, again, this is something that I say for every survey. It's important that you have your voice heard, first thing. This is actually the one opportunity for students during the course, normal workflow, to be heard about problems that are in classes or things that are working well. And two, it's important that when you have your voice heard, you share everything that you have on your mind, meaning positive, negative, even I would say neutral. If we have a bunch of people in a class that say, meh, it's okay, but meh, that still send us a message, okay? Of course, we would prefer, as opposed to meh, like an open-ended question, comment that gives us a clue about what is so. But anyway, bottom line is, yes, please take a look. You should have already the link in your inbox, okay? You should have received a mail for that. I forgot the name of the system we use, Blue something. Take those if you can on your own time. Otherwise, I will make some time during class next session, for example, so that you can take the survey during the class time. Okay? All right, and that's it for the announcement. So the things that we kind of went fast, a little bit fast. I mean, I left that one completely for you to do, I think. This one, same thing. And the sorting we didn't touch at all. Okay, so it was already in the slides. Those of you who were curious, you already picked ahead. Very good for you. You saw those things. Otherwise, I want to make sure everybody's on the same page. So I'm going to go real quick over this stuff. And then we're going to transition to module 10. So the first thing, binary dichotomic search. So we talked we talked about the principle in its full extent. Okay, so that was the algorithm that we described last time. Figure out what is the middle of the array, test if the key that we're looking for is lesser, equal, or greater than the middle element of the array. Exactly like you would do, trying to flip through a dictionary. And we saw an example of that, where the key, for example, is 8. This is my array. So remember, to be able to do, so first thing, binary search is a boost. Binary search is more performant than linear search. First thing to remember. Second thing to remember, it's not magical. To gain that performance, you have additional constraints, you have additional cost to pay. The cost is your array should be sorted. So every time you see me like trace through a binary search, you're going to see an array that is sorted. We pick ascending order from smaller to bigger, right? But it doesn't matter. We can rewrite the algorithm so that it works ascending or descending. That's not a big deal, okay? But by default here, I'm going to always assume ascending order and write my algorithm accordingly. So here I'm looking for 8. First thing, I figure out the middle. It's 4. So I look at the algorithm on the left, right? Because 8 is greater than 4, then I'm going to search in the second half of the array. I figure out which one is the middle. And every time we figure out which one is the middle, there's going to be some integer division. Okay? I'm going to say I want to make the difference between those indexes, divide by 2, and it's going to give me something that as an integer is going to be rounded down by 1 position. So if I have an even number of elements in one of my subarrays, that's going to round down. If I have an odd number of elements in my subarray, okay, then that's not a problem. So we're going to do the division, check as the index, and then figure out that, well, we need to look to the right of this because 8 is greater than 7 again. And then our array is getting smaller and smaller and smaller and smaller. Okay. So we keep track of where the array starts, index 0, where it ends. And then we say, okay, now I want to fix the start and end here. Now I want to fix the start and end here. And every time we look for the middle element and we compare ourselves to the middle element. When we have an array of only 2 elements, this is a start index, this is the end index, the middle element is going to give me that. That's okay. It's kind of funky, it's kind of weird, right? But that's okay. I'm going to compare myself to 8. And then what? If I find 8, the value I was looking for, then everything is good. I can return that index. If I don't find it, what's going to happen? Well, I keep reducing the boundaries of my array. At some point, if I try to reduce this, the pointer that tells me, this is a start index and the pointer that tells me this is the end index, they're going to pass one another. That's how I'm going to detect that I'm done, completely done with my array. So it's a lot more complicated than just, looking at element index 0, then 1, then 2, all of those iterations that we have been doing until now. So the linear iteration are what you should be comfortable with in this class. Thus, we're stretching a little bit, okay? We're stretching a little bit to prepare you for what's coming up next. It's a smarter way to move around in an array. The first time, it's really a hard pill to swallow for some people, but you are going to get used to it because we are going to cover it again and again and again in multiple classes, okay? So, let's take a look at that binary search method. We're going to jump into coding bat. Oh, sorry, coding bat. Wow. Into JGrasp. We're going to jump into JGrasp and we're going to take a look at that, how we can work out this method. So I told you that we need to keep track of where my array starts and where my array ends. So I'm going to use 2 variables. I could call them start, end, low, high, whatever makes sense for you. Okay, I'm going to use low and high. So int low, int high. So this is going to be the index of the start of subarray. So what I call the subarray is a part of the array that I consider. And this is going to be the index of the end of subarray. What can I initialize them with? Well, at the beginning, I consider the whole array. So the start index will be always 0, no problem. For the high, what is the last valid index in an array? So if you give me an array called list, for example, and I'm going to get out of the main in a minute. I don't know why I started here. I'm going to take list.length, so the number of element minus 1. That's always been the last index of my array. Now, I said I'm going to get out of the main because I don't know why I started writing the stuff in the main here. I was not paying attention, obviously. Public static, so int binary search, and it takes as parameter an array. We call it list, okay, that we want to search. And it takes as parameter as well a key that we want to search for in the array, okay? So this code here belongs definitely in my binary search method. So I'm going to grab it and I'm going to paste it here. There we go. All right, so I have my first 2 indexes. Then what did we say about the iterations, the main iteration? We are going to keep looking for the middle, divide like by 2, etc., to find the index of the middle element, compare ourselves meaning the key to the middle element, and decide whether we want to continue our search in the second half or the first half of the current subarray. Okay, and what we said is that at some point, the indexes we use to keep track of where the subarray starts and ends, they are going to cross over. Okay, what does that mean, they cross over? That means that the index for the low position is going to become higher than the index for the end position. Okay, so I can write a loop like this. So I'm going to use a while loop. Again, we could do it like a bunch of different ways, okay? And while loop. And I'm going to say while high is greater or equal to low. Okay? So high greater or equal to low, that's exactly the condition I was talking about right now. Again, I'm going to write it one way. But one thing that I encourage you to do with this little exercise is try to rewrite it your own way. Study it, learn how it works, and then go to bed, sleep, do something else, do something fun, come back the next day and try to rewrite it without looking at the solution. But the idea is don't force yourself to remember all the steps one by one. Okay, remembering is going to carry you so far, down the stream with programming. Try to understand the logic here and try to come up with your own expression of that logic. There are many different ways we can write this. Okay, so don't stick to just memorizing one possible solution. All right, so I have my loop here, and then what we talked about doing repetitively is compute the index of the middle element. So I'm going to call this mid, and I'm going to say the index of the middle element is low plus I divided by 2. Everything is an int. 2 is obviously an int literal. Low and I are int variables. So all of this is going to be an integer division. So this is where the rounding is going to come from. Okay, actually it's not really rounding, it's truncating. If I find that my array has 5 elements, I divide that by 2.5, I'm going to look at index 2, okay, and so on and so forth. So that's computing the index of the middle element. Now I need to look at the middle element. The algorithm that I had told me to compare the key to the middle element and do something if it's lesser than, something else if it's equal, something else if it's greater. So let's go for it. We are going to have a bunch of if else, okay? So let's start by the possibility that the key is lesser than the middle element. So if key is lesser than, how do I get the middle element? List index mid, okay? If the key is lesser than the middle element, then I'm going to change the boundaries of my subarray. Okay? So what does it mean that the key is lesser than the middle element? The key being lesser than the middle element means that if the key is present, I use lesser string, by the way, so it's not equal, right? If the key is present, it's in the first half of my subarray. My subarray starts at at low, ends at high. I'm right here in the middle, right? So now what I want to say is I want to say that for the new subarray I'm going to search, the high index is pretty much the middle minus 1. That's going to allow me to say, I'm considering this subarray. The middle is this way. Okay, so shorten the array that I'm looking into. So to write this, easy, high equal mid minus 1. I'm not using curly braces because I think I can keep it to one statement per if condition. So here's my first if. If the key is lesser than the middle element, then redefine where we are going to search next. Okay, I don't return anything yet because high is still greater or equal to low, so the search can continue. I certainly haven't found the element, so I'm just resizing it. And then what the algorithm tells us to do is to check if key is greater than, so the opposite, if key is greater than mid. And I could not just use else, because there is a third possibility that key is equal to list index mid, okay? So I cannot just say like else and then do what I'm about to do right now. What I'm about to do right now is the opposite, low equal low plus 1. So if I have to search in the second half of the current subarray, right, I'm going to say this is low and high for my subarray, my current subarray. I looked at the middle element. I know the key is going to be in this half, so I change the low to be the middle plus 1. So notice that I avoid the middle, okay? I just looked at the middle. It's not the key. It's either lesser than strict or greater than strict. So I'm going to leave the middle element alone, and I'm going to start my boundary at 1 plus the index of the middle element, or middle element index minus 1. Okay? That, by the way, that plus 1 minus 1 is also why when I have high and low that are like next to one another, okay, I'm going to cause things to cross over. or the index is at the very least to become equal. When that happens, then it's going to be a special case. Yeah. Sorry, you have to say that again. Yeah, it should be mid plus one. Good catch. Do you have the same question? Yeah. Yeah, good catch. Sorry about that. So yeah, this is definitely mid plus one. The narrative was disconnected from the typing there for a minute. Thank you. All right. So mid plus one, mid minus one. Sorry, that makes more sense. And then what am I left with? Well, what I'm left with is T equal least index mid. If it's not lesser strict, if it's not greater strict, so it's not different. That means it's equal. I don't need to do the test. This is a mistake, quote unquote mistake, okay? This is something that beginning programmers do. They tend to do extraneous testing. Why don't I need to test if T is equal to least index mid? Because by elimination, that's the only thing that can be true if I reach that else. Because that was false, okay? So it's okay. When you write code, if you tend to write too many tests, too many conditions, that's because you're still thinking about how to develop your solution, and you tend to write down, to pretty much do a brain dump of your IDs into the program. That's fine. As long as it works, you're okay for this class. Eventually, I want you to start being aware that, refactoring is important, meaning that if you can simplify your code, yeah, you remove opportunities for bug. So go for it. So in this case here, I'm going to go with a simplified version directly, and I'm going to say else. So what do I do here? I found it. I found actually the element that I was looking for. What is the index at which that element occurs? Mid. Okay. So either start searching at mid plus one up to the end, or start searching at the beginning of the subarray to mid minus one, or we found it, return mid. So the version that we have here of the algorithm is called an iterative solution. We're not done yet. We need to do one more return, but real quick, a remark. It's called an iterative solution because it is based on a loop. With what we've learned to do so far together, this is exactly what we would go for. Now, there is another implementation of the same algorithm that you are going to probably talk about in COP2512, or we'll talk about it next week very briefly. If everything is going well with the final preparation, I'll make a little bit of time for it. The other version of this is using recursion. So you are going to encounter, again, that same problem and that same algorithm, so the same solution, but you are going to learn very soon to implement it completely differently by, instead of using a loop like this, you're going to call the function repetitively again. So more about that very soon. I just want to point out that this is one of the, one of the easy, quote unquote, easy-ish example of recursion that people study when they just discover that concept, okay? So I mentioned that there was something else missing. Well, if I try to compile this, the compiler should even be able to tell me actually. Yeah, missing return statement. So I can reach the end of my code, and that doesn't mean that I triggered that else. I didn't find the key anywhere. My condition for the while ended up being false. Now I'm out. I still haven't returned anything. So this is where I told you, for your version, don't bother, just return -1. Okay. Now, if you are a little curious, right here, when the instruction told you you should return minus the insertion point, -1. So here's the -1, doesn't change, and minus the insertion point, that's low. The index low just happens to be, if we get out of the loop, it just happens to be where I would like the number to be inserted if I was to add it to my array. So it doesn't cost us anything extra really to implement that feature. But for a first introduction to binary search, really, if you just do return -1, that's already pretty good. Okay. So I'm going to leave that in there. I think I have it on the slide too. But don't worry too much about this part. Okay, this is really not the essential. Returning -1 would be just fine for a first version. So let's make sure that this compiles. It compiles. And now we're going to give it a little whirl. So how do I test that? Int data, and I'm not going to do anything fancy. 3, 4, 5, 6, 7, 8. Right? So an array of 8 elements. And then what I want to do is I want to call binary search. I want to pass this, and I want to say, for example, tell me where the value 9 is located. And we're going to play a little like that to make sure that we can find different elements, okay, different elements, and make sure that we can also handle the fact that sometimes we look for elements that are not there. So let's compile this, run this. So it tells me minus 9. So again, the insertion element, okay, not really relevant, but this is index 0. This is index 7. It's telling me pretty much after the end of the array, okay? So that might be actually off by 1. I'll have to look at it in more detail, but I'm not going to take time to look into that right now, okay? The important thing is like it's minus something, that means it was not found. Now, more interestingly, let's see if we actually get correct result when we are looking for something like, for example, 1. It might be a +1, -1 adjustment to do there. So if I run that, so element index 0 is 1. So it tells me, yes, you are going to find it at index 0. I found it actually at index 0. So when we test, we like to test boundaries, right? We like to test extreme cases first. So I have one test where I tested with 9. I tested 1, then I'm going to test the last element, make sure that the algorithm can find the value if it's in the last position. Bingo. It can definitely find it, no problem. And then what's left to do? Well, I would probably do a test in the middle, just for the sake of completude, like avoiding a weird bug that makes it work only on the ends for whatever reason. And there we go. 4 is at index 3. That's correct as well. Okay. So we implemented our little binary search method. You're going to have the code for this in the slide. Actually, you had already the code for this in the slide if you studied a little ahead, okay? And now I'm going to show you like something else that is actually so much more practical. So we do this to learn. We do this to become better programmer. But when you are actually coding and you need to search in an array for a value, and you know that array is already sorted, right? You're not going to rewrite this. People did that for long enough. Nowadays, any modern language is going to come with a standard library of methods, and these are going to include sorting algorithms, searching algorithm, and all that good jazz. So practically, once you are out of learning, your learning phase for a programming language, you won't have to re-implement this ever. Okay, this is just a little exercise that we need for, well, getting practice with the language, getting practice with the design of algorithm, and also making sure that you understand what a binary search is, not just use blindly something, like a script kiddie. So once you are done learning with this is what you want to use. So we have been doing a few different imports, okay? I think we already imported actually java.util.arrays. I think it was for the arrays array copy, I think, method or something like that. So, but bottom line is the method I'm going to tell you about right now comes also from that package. So java.utils, that means utilities. So there's a lot of stuff in that package, arrays, utilities related to arrays, of course. The method that we are interested in is called binary search. Well, it's called binary search because that's exactly what it implements, a binary search over an array. What we have here is we have in this little fragment of code, we have one first array here that is made of integer value, starting with 2, ending with 79. And these values are kind of random, but they are sorted. Always remember, binary search, you need things to be sorted. I'm going to say system.out.println the index is, and I'm looking for value 11 in that array. So how do I do it? java.util.arrays.binary search list, 11. That's it. I call the method. It exists already. No point in re-implementing it, once you are working on a project. One thing that I left here in the slide, I considered removing that, but I could have written arrays.binary search. That's what we have been doing until now. Okay, we did always math.square root, array system copy, whatever. So why did I write java.util? Just to make a side remark about it. This would be the fully qualified name of the method binary search. The base name of the method binary search is, well, binary search. That's the name, public static, blah, 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 binary search. That's the name that you use when you declare a method. It is inside a class named arrays. We have learned to do that. Now we can put, our method in a class, and then we can call the method from that class from another file, and we just write the name of the class dot the name of the method. Why this? This is in case I don't want to do the import. So if I do import java.util.arrays, that means when I say arrays, the compiler is going to understand that I'm referring to the package java.util.arrays. If I don't import this, I can always tell the compiler, hey, I'm trying to use a method that is in that class, but that class is located inside that Java package. So java.util.arrays, the name of the class with a full path where to find it in the standard library, and then .binary search, the name of the method, and here we go. Okay, so it's just another way to note methods that you are trying to call from the JDK or from other classes that you wrote. We have not been writing packages in Java in this introduction, but if we were to make our own package, which honestly doesn't take much more effort, then we could also access the method in those packages like so. And what is this? This is a char array containing A, C, G, X, Y, and Z characters. Same thing. I'm calling the same method. I'm displaying the index of looking up for the letter T that is actually not in the array. So the second example illustrates that the java.util.arrays.binary search method is actually overloaded. We talked a little bit about overloading. We are going to talk a lot more about it in COP2513, okay? But what we said about overloading is, well, sometimes you can have a method, and that method, for example, math.abs, has different version implemented. One version that they're all called ABS, absolute value, but one of them is going to accept a double as parameter. One of them is going to accept an int. One of them is going to accept, etc. So overloading, the concept of overloading is I have a method, and I want several versions of the method that are able to work on different types of data, okay, different data types. That's exactly what we have here. So this version here took list and an int as parameter, list being an array of int. This version here takes a char and an array of char as parameter. And there are multiple versions that cover actually our needs for pretty much, the Boolean is not there because, yeah, searching for true or false in an array, I guess, is not that challenging. It doesn't justify binary search. But int, double, char, short, long, float, the usual suspects, the Java primitive data types are covered. So whatever type of array you have, as long as it's not an array of references, we're going to cover how to sort them and search for them in COP2513. It's a little bit more involved, but as long as you have an array of primitive data types, you can actually search for it after sorting it with a binary search that is already implemented for you. Okay? So if we run that, that's going to return, doesn't matter what it returns. It's the same definition that we had before. Just remember the array must be pre-sorted. And that's it for the binary search. Just out of sheer curiosity, how many of you find the binary search intimidating? Yeah? Only that many? Okay, so, okay. I was going to say, I'm going to put that as a final. This is awesome. So, binary search, I'm not going to expect you to write it by yourself, but if I gave you the algorithm, so let's treat a little the concept. If I gave you the description of the steps you have to follow so that you can code it, would you have problem coding this method, you think? So use like sign language a little bit, like if you would have problems coding it, Or if you would not have problem, let's go positive. Raise your hand, please, real quick. Okay. So self-checkout for the final exam. At the final exam, my expectation is if I give you the algorithm, right, then I'm not asking you to problem solve. I'm asking you to actually code from English to Java. So keep that in mind, okay? If I give you the list of steps in English, you should be pretty much able to code anything as long as I don't mess up, giving you the instruction, or I don't make them confusing, or I don't make them using some Java features that we never talked about in class. But if I keep it fair, the expectation is that as long as I give you the whole solution, you can translate any algorithm into Java. First thing. So don't get intimidated by binary search. Sorting, binary search. If somebody gives you the algorithm, you should be able to implement it. First thing. Second thing, coming up with that algorithm, no, don't worry. We're not there yet. This is going to be probably progressively ramped up in COP2512 and fully covered in data structure. That's the kind of stuff we are dealing with here. The second thing that I left pending last time, and I asked you to take a look at it, was that tokenizer extra practice exercise. Well, the tokenizer itself is not that super exciting right now because we already covered it at least 2 times. So even though it's not a trivial algorithm, we have seen already at least 2 versions of it. So I'm not going to live code that part. I'm going to cheat. I'm going to cut and paste from somewhere and kind of go fast over this, okay? But one of the things that we discussed about was separating in several files the code for this project. So this is still relatively new, so I'm going to show it to you again, demonstrate it to you again. We already covered that 2 times, I think, so far. And then there was this add token method. This add token method is actually new, so let's focus on that one. So again, back to coding that. We are going to need some new files. So let me check the description here because we need 2 files. We need mystringlib.java. There we go. So this is where we're going to put our tokenizer. So let's go for it. Create that one first. Java file, and I want mystringlib.java. So this is where I'm going to do the crazy cut and paste to save us time. So we go public class mystringlibs, and I'm going to snatch the tokenize method. So it's really a small variant of the tokenizer that we already covered and learned to love. Okay, so I have a tokenize method here, real quick. So you give me a string. I'm going to break it down into its constituent words, separated by one or several spaces, return that as an array of strings. So this is kind of the novelty, is that we create an array of string instead of just displaying the word one by one on the screen. So I create an array named tokens, an array of string named tokens, and I say it's null. So we have not done that too many times in this introduction to programming, but we are going to start doing it more and more often. And in COP2513, that's going to be the default. Whenever I declare a reference variable, if I don't want to create an object right now, like for example here, I don't know how big my array tokens needs to be, because it's supposed to contain 1 element per word in the sentence. I have your sentence, but I haven't checked it out yet. So I don't know how many words are in there. So guess what? I'm going to say, I don't have an array of string yet for you. I'm not going to create it right now. I'm going to wait that I know how many words I need or something like that. Null is a placeholder. That means in the context of a reference, I don't have an object to refer to. Okay. Interesting little tidbit. If I was trying to access tokens, the contents of tokens index 0, token index 1, or something like that, or call a method on that array, because it's null, then I would get this nice little exception that you guys are going to see over and over and over. Some of you already encountered it, which is null reference exception or null pointer exception. I don't remember how it's phrased in Java. Bottom line is that it tells you, hey, you had a reference to null, and you act like you were trying to access the object being referred to. There's no object. Boom, everything falls apart. Okay, so that's one thing that's very common in Java programming. And that's also common in C programming. So you guys are going to encounter it in two different classes. We are going to learn how to deal with that and work around, those null value and make sure we don't try to use a null value. The second thing is I take your sentence and I trim it. And I'm going to trim it like a few times, like 2 times, I think, in this version of the code, just to remove those extra space as a beginning and at the end of the method. Here's an infinite loop. So now I look at the draft version of my string, the one that I trimmed, and I look for a space. If I do not find a space, I check the length of the current string that I'm looking at. If it's greater than 0, then that means there's no space ahead, but there are a few characters here. So that means everything between now and the end of the string is going to be the last word in your sentence. So I mark that by saying index is going to be draft.length. So index is going to be pretty much where I end the word. So since I didn't find a space, I'm saying pretty much go to the end of the string. Else, well, if I didn't find a space and there's nothing left, no character left, then we're done here. Break out of the loop. Once I'm done with that pre-work here, I'm going to copy the token that I'm looking for. So I'm saying the next word is draft.substring between 0 and index, and then for good measure, trim. Always get rid of those extra spaces, okay? So now I have the word, and this is the part that is completely new. Everything that I covered so far was kind of a slight variation of the one version that we studied together. This is completely new. Now I'm saying the tokens, so the array that's supposed to contain every word in the string, is going to be replaced. Well, that's not a big deal. It's not a big loss so far because my tokens array was null, right? So my tokens reference variable said, no, I don't have a tokens array. So what I'm saying is I'm calling the add token method and I give it the current reference to the current array of tokens, so null, and I give it a reference to the string that represents the next word, and I tell it pretty much resize that array, make room for one more, and add that word as the last element. And then return to me the reference to the new, bigger, improved array. And I put that in tokens. And then next iteration, I'll say, you know what? Here's that array that you already extended for me. I give it to you again. Can you extend it once more and add one more word at the end? Thank you. Get back the reference. And then keep doing that. Okay. Every time I find a new word, well, here's the old array. Make it bigger and add the last word at the end. And keep doing that. Okay. So this is a part that's completely new. And then that last part, we had a version of that going on in our previous attempt at this code. What we're saying here is that I'm going to move forward in your sentence. So now that I have found actually a word, I'm going to say whatever is left for me to look at is everything after the end of this word. Yeah. Yes, very good question. So this is something that we didn't talk a lot about. Again, what I mean by a lot is I'm trying to figure out if we had ever an example of that before today. No? Okay. So very good point to bring it up. What we are doing here when we write draft.substring of index.trim empty parentheses is we are doing something called chaining method calls. Okay? It works this way. I have draft here. It's a reference to a string. Draft, I use that reference to the string, and I call on it the method substring. Okay? Calling the method substring on a reference to a string is going to create a new string and return to me the reference to that new string. So this whole part here, draft.substring of index, is going to be replaced by a reference to a string. What can I do with a reference to a string? I can call methods on it. Dot trim. So that means take the draft string, call substring on it, get a new reference, take that new reference, call trim on it, get a new reference, take that new reference, assign it to draft. So we chain with one another the methods. The result of one method is passed pretty much, is used to call another method. Yeah. 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 In Java, yeah, the question is, can you use that only with objects? So in Java, definitely, because you can call objects only, you can call method only on classes or objects. Okay. Now, there are programming language, Ruby comes to mind, where there's no difference, there's no primitive data types and reference data type. Everything is a reference data type, everything is an object coming from a class. When you're working with such a language, then you don't even ask yourselves the question. If you want, you could write 5 dot and call a method, from the class integer. You see what I'm saying? In Java, this is not object-oriented. The object-oriented model is not as ubiquitous in the language. And this is mostly for performance reasons. People try to make it so that for very small operation that we can do on primitive data types, we have a separate category of types that allow us to do pretty much what we do in C in terms of programming, but a lot faster than if we were using the Java objects. Does that make sense? Cool. All right. So that's our method tokenize. So now what we need to do this stuff. We need to do add token. So let's go past the end of tokenize. And again, in the interest of saving a little bit of time, I'm going to at least cut and paste it by morsels, okay? So let me get rid of tokenize here. And we are going to do, so let's start with the signature of the method. So this is going to be my add token signature and add token. So this is straight from the instruction, right? Nothing there fancy. Now I need to think a little bit about how I'm going to organize that method. So the idea of this method is you are going to give me a reference to an array. The one new thing that I'm injecting here in the exercise is this reference might be null. Okay, there's a possibility that you tell me I don't have an array yet. So I cannot just assume you're going to give me an array and I can start looking into it or doing things with it. No, maybe you're giving me a reference, and if the reference is null and I try to use that reference, everything's going to go kablemo. So instead, I'm going to have to start looking at, well, is that tokens null? If it's null, I don't even have an array. So you know what? I should create an array of size 1. And that's what I'm going to return, right? If tokens is not null, then there are already elements, there are already words that you found. So I'm going to have to measure the length of tokens. I'm going to have to create an array that is that same length plus 1, and then put my token second parameter at the end of it. So how do I do this? So let's start by measuring the length of the array tokens, okay? So the first thing that we do when we measure the length of an array, we do tokens.length. And that's why I want to use this example, because it illustrates how the null values can be a pain in the rear. If I write tokens.length, I'm saying take the reference inside tokens, go to the object being referred to, and check the length of that array. Well, that's all well, as long as people give me an array. If they give me null, boom, my program explodes at runtime. So instead, what I'm going to do is I'm going to have to use a if statement. I'm going to say if tokens is null, then the length is 0. Else, the length is tokens.length. So I use the ternary conditional operator just for brevity, okay? Keep it brief, keep it short, but it's just saying pretty much that either I have an array, in which case I'm going to get a length, or I don't have an array, in which case I'm going to say the length is 0. You would assume that if you try to get the length of an array using the reference variable null, you would get a 0. But that makes sense in common sense, but in practicality, it's not how it works. Java is going to try to follow that null reference. Yeah.
So I noticed that you put a semicolon and a semicolon. Is that supposed to be like that?
Yes, that's correct. It's not a typo. This here, tokens equal null question mark. So this is a syntax for the ternary conditional operator. So quick reminder, we didn't use it often, okay? So the reminder is this is a condition. The question mark say, is this condition true? If the condition is true, then this whole expression here is going to be equal to this value. Colon, the colon means else. If this expression is not true, then else the whole expression here is going to be equal to this value. So that's kind of a version of an if-else statement. That's an expression instead of being a statement. Remember the difference between statements and expressions? Statements do things, like a loop, a conditional, etc. Expression, they do things as well, but they result in a value. So here we have a way to say this whole thing is going to be either this or that. Make sense? Cool. Don't hesitate to jump in, okay? When I use like weird stuff like that and it doesn't really click, please jump in. All right, so we have a way to measure the length, and more importantly, we do it in a safe manner. Safe manner meaning that if token is null, we don't explode. So what are we going to do with this length? So again, I'm going to try to save us a little bit of typing time at least. So I want to create a new array. I'm going to call it new tokens. It's an array of string, so same as tokens, and it's going to be therefore an array of string of size, whatever the length is, plus one. So once I am done here, taking into consideration that tokens might be null, I can go forward and just like use the length. So now I'm using len plus one, no problem. If it was 0, the result is 1. If it was 5, then the result is 6, right? So I just keep adding 1 to whatever I add. So this is creating a new array that is one element bigger than the one that you passed to me as parameter. And then the last thing I have to do is I have to actually copy all the elements from the old array into this new array. First thing, I have two things I have to do. And second thing, put that one word as the last element of the new array. So how do I copy all of the elements from the old array to the new array? Well, let me again cut and paste this. I'm not sure the cut and paste is going faster than typing by that much, but at least it provides some guarantee against typos and stuff like that that would waste our time otherwise. So I'm going to use that since we're a little short here. So system.arrayCopy source. So again, this is something that we've seen once or twice. We haven't used it much. Okay. So this is a source array, the old array tokens. I'm going to start copying the reference that are in it at index 0. I'm going to write them in the new tokens array, starting also at index 0. So both arrays are going to start at index 0. Copy this here, increment, copy this here, increment, copy this here. And then how many times do I do that? The length of the old array. Okay, so I'm going to copy all the value from the old array, and then at the end there will be one extra space in the new array because I allocated it to be bigger. If I try to do that, I have to be careful again. I have to be careful because I'm going to go look up into the array referred to by tokens. Tokens can be null. I have to be careful here already. If tokens is null, and I pass this to array copy, when array copy tries to go and fetch the value inside token, it's going to create an exception again. It's going to crash my program because there's no array that was found. So again, I'm going to have to be careful and do something like if tokens different than null, then I copy. If you gave me a token array, then I'm going to look into it and copy the old element. What if token is null? What would be the else here? Well, the else is nothing. If tokens is null, that means, well, you pass null as that first parameter, which means that I created here a new array of one element. How many elements do I need to copy over from an array that doesn't exist? 0. So my job is done here. I don't have to copy over any old element. I just have to take care of the last element, the new one that I want to add at the end. So that's it for that if. It's going to be a half if statement. Okay. And then what's left? Well, once I am done, meaning that either I copied the old elements or I skipped that phase, then I'm going to put in the last slot of the array new token, I'm going to put the value token, which is my second parameter. New tokens of len equal token. Okay? So that's going to ensure, so I use len because len is the length of the old array, right? So my array, my new array, new token is of size len plus 1. So that's why this is valid. Otherwise, generally, if this was the length of new token, we never store anything at an index that is the length of an array. So here I'm adding the last element at the end, and I think we're pretty much done with this. So I'm going to compile to see if I introduce some typo at some point. Hopefully no, because I did all that cut and paste. So here's my string lib.java. Yes, I did manage to introduce a typo. It's a missing curly brace. Oh no, missing return statement. Yeah, I forgot to return new tokens. Still managed to make a typo in there. All right. So I'm not going to run it because I don't have a main method yet, but that's what I'm going to work on next. So work on next, I need a new Java file. I'm going to call it my string lib test or something like that, whatever the requirement wanted. And that one I'm not going to even like write like little step by little step, because this is stuff that we have seen over and over and over. So I'm just going to inject the code directly here. We're going to save that file. There we go. It has a main method. I'm just going to go over it real quick to make sure there's nothing magical in there. It has a main method, creates a scanner. Then I'm going to read a line, an entire line from the user. Then I'm going to call my method, my string lib, that tokenize on that input, get back an array of words. And then I'm going to say, I have found this many tokens in your sentence, this many words. Then I use a for each loop to iterate over the array of words, and I display each word with those square bracket around it, so that if I messed up, and there was a space at the beginning or a space at the end of the word that's left over, then the square bracket would allow me to visualize that very easily. That's the only reason for which I have the square bracket. It's not a syntactical thing. So let's try to compile this. Let's try to run it. So there should be a prompt. So I'm going to put several space. Good people. There we go. And this is a tokenizer. So the tokenizer, we saw it run before in other variants, okay? This one is running, but it's not the tokenize method that is displaying things on the screen anymore. The tokenize method returns an array of strings, and then I choose to display them like that. It's a word of difference, okay? If you give me a method that computes the square root of a number and displays it on the screen, I'm not going to use that method, because maybe I'm developing in Java, but maybe I'm developing on the Android platform. I don't have a console. Nobody looks at the console on Android. Why do you want me to display anything on the console? I want the square root to return a value, and I'll decide if I want to write it in a file, write it on the console, send it over the network. Whatever I want to do is my business. So that's why most of the reusable methods that we put in separate Java file, right? These are methods that are going to take some input as parameter, return some value, or modify the parameter. But they very seldom display things on the screen or write things into a file, except if that's their explicit job. For example, if I write a method display array, yeah, it's going to write to the console. If I write a method save array into a text file, it's going to write into a file. But the vast majority of methods, they don't do any of those side effects into file, databases, console, etc., because they want to be maximally reusable, okay? And if I was to write in a file, I would probably take the file name as a parameter so that it can be used with any file name that you want me to write to, okay? So we are starting to touch here to the point where we want to make our code as reusable as possible, and that's definitely something that we're going to dig into much more again in COP2513. All right, back to the slide. There was one last point, so it took me a little longer than I thought. There was one last point here that I left completely do it yourself alone in the last lecture, so I'm going to rectify this. Sorting arrays. So searching is a common operation. We saw that there is an inefficient way to search, linear search, and there is an efficient way to search, binary search. But to use that one, we need to sort an array. So there's been a lot of work that has been put into sorting algorithms. Most of them, you are going to study them in data structure, but let me give you one very simple sorting algorithm, and you are going to probably use something similar in 2513 and then COP 3515 as well, okay, when you study the C language. So we always pick like one of the simple, quote unquote, simple, sorting algorithm. It's not simple the first time you see it, but after like a few iterations, it's going to be a lot better. So we use one of those inefficient algorithms because they are easy to understand. And just like with linear and binary search, this is a linear equivalent of a sorting algorithm. If you want to make this analogy, it's very simple to write, but it's really not performant. And then there is the equivalent of binary searches for sorting algorithm, where the algorithm is much more performant, but requires a lot more complexity. So let's look at our first version of a sorting algorithm, the very first sorting algorithm we are going to study together, and how it's supposed to work. So I have an array of values here. They are not sorted. If they were sorted, I would not bother with any of this, okay? So the values are not sorted, and I want to sort them in ascending order. Everything that I say about ascending order, generally there's one thing to modify in a sorting algorithm, one comparison, and suddenly you sort in the other way around, right? So I'm going to show you the code for sorting in ascending order. If you wanted to sort in descending order, from the largest to the smallest, then you would just change one piece of the code that I'm going to point out to you when we get there. The logic of this algorithm is to go through every element in the array, find the smallest, select it. Select it just means take it pretty much, and put it at the beginning of the array. It's called selection sort for that reason. We go through every element, we find the smallest, we make sure it ends up at the beginning of the array. Easy enough, but then we are not done. Now that we know that we put the smallest of all the elements at the front of the array, we move one step forward in our array. So we don't care anymore about index 0 because we have already the smallest element there. And now what we do is we start looking at index 1 and we look through every remaining element in the array, starting at index 1 to the end. We find the smallest in what's left, and we put it at index 1. Now, index 0 was the smallest of them all. Index 1 is the smallest of what's left. I move forward in my array. I am now looking at index 2. I'm going to start from index 2 to the end of the array, look for the smallest value in whatever is left of my array. Put it here. Move forward, take the smallest, put it here. Move forward, take, etc. Okay? So this is pretty much what this illustrates. So let's take a look at the details step by step. So I start by saying, okay, I have my array. I'm going to look at the first element. Right now it contains a 2. I compare 2 and 9. Well, 2 is smaller, so it should be at the front. 2 and 5. 2 is smaller, should be at the front. 2 and 4, same thing. 2 and 8, same thing. 2 and 1. When I compare 2 and 1, I realize that 1 is smaller than 2. It should be at the front. So I swap them. Okay? And I'm done. I'm done for this run. Actually, no, I'm not done. I would compare also the 6, but the 6 is bigger, so I don't have anything to do. Once I have put the 1 at the front, then I do exactly the same job. So I'm talking about a loop here. There's a loop that's going to say, find the smallest, put it at index 0. Then find the next smallest, put it at index 1. Then find the next smallest, put it at index 2. So that's one loop that's going to go through every position in the array. Inside this loop, there's going to be another loop. The other loop is going to say, now that I'm looking at, for example, this element at index 1, right, second position in the array, I want to make a loop to compare it to the next one, then the next one, then the next one, then the next one, then the next one. When I compare 9 to 5, 4, 8, okay, I'm going to possibly switch like every time, but I'm going to end up actually with finding that 2 is the smallest, switch it, and then move on to the next example, the next position. So that's pretty much the logic of the array. We have 2 loops, one inside of another, and they are going to iterate over every position of the array, and for every position of the array, find the smallest element that could go there. So that one, I'm just going to illustrate it like that directly in the slide. I don't think it's worth doing the live coding because this is really, this is kind of like the keystone for this course. Okay, we end up finishing the introduction to programming by touching a little bit to sorting and searching in arrays, right? But we try to do it really gently, okay? Not overwhelm you, just give you a test of things to come in the next course. So I'm not going to ask you to to come up with this kind of algorithm on your own. First thing, set the expectation. Second thing, but if I gave you the pseudocode, if I told you first, write a for loop that does this and this, then do this, then declare this, write another loop, then yes, I would expect you to be able to translate. So think of it in that term, right? I don't expect you to be able to write a novel in German because you just studied German for a few years, but I could expect you to translate word by word, in an approximate manner, a text in English into German or vice versa, right? These are two different type of programming problem. One is implementing, one is actually problem solving and programming. So let's take a look here. Let's just look through it real quick. Let's take a look and see what's happening. So the selection sort method returns nothing, void, and takes an array of double as parameter. So that's the array I want to sort. How does that work? If you give me a parameter, can I actually change that parameter? Well, no, Java is passing by value, but wait a minute, this is a reference to an object. So you give me a reference to an array, that means that this method can use that reference, cannot do much on the reference, but it can use that reference to go mess around with the content of the array. We've seen that a few times already, okay? So yes, this method will be able to change what is inside the array. And when it's done executing, whoever passed the reference to one of their array, like the main, for example, is going to see the changes in their array as well. First loop, that looks like the recipe for, I want to iterate over every element of the array. That's exactly what it is. Counter control loop with an index that starts at 0, goes up to list.length -1, increment by 1 every time. I'm going to say that my current minimum is whatever is at index I. So remember, index I, say, I look at index 0, let's find the smallest element, put it here. Then I look at index 1, so I equals 0, then I equal 1, find the smallest, put it here. So when I start I equals 0, I'm going to say the current minimum is the element at index 0 inside of list. So I assume that what's at the front of my subarray is already the smallest element. And I say this current element, minimal element index is 0, the index of I. So I say, hey, this is a value in this variable, and I say this is where it's located at index 0. And then I have another loop inside. Okay? The other loop says, okay, you're looking at index 0, so let's start at 1 up to the end. If I was looking at index 5, I would start at 6 up to the end. So that means start at j, index j, equal I plus 1. The next one. And consider it. Is it smaller or not? And then do that until you reach the end of the array, j++. And every time we say, if the current minimum that I have is actually greater than the element that I'm looking at in the remainder of the array, then I say, forget that. My new current minimum is that element over there, and its index is j. So I take note as I go through the array, I note down what is the smallest value that I've encountered and at what index I've encountered it. But I didn't swap anything yet. I just scan through the array, find the smallest element, and the index where it lives. And when I'm done doing that, then I'm going to say, oh, if I found like a different element that's smaller, so my index changed, then I'm going to swap those guys. That's it. I'm doing the swap between the first position and whatever position of the smallest element I found. And then go back, iterate again. So I solve the problem of putting the smallest value at index 0. Let's go and solve the problem of putting the second smallest value at index 1. So it's like I'm looking at the array starting at index 1, I repeat and rinse the same thing. Okay? As with the search, this is for learning. By the time you finish data structure, trust me, this kind of algorithm will make a lot more sense. But it's going to take 4 courses to get you there. This is just the preliminary test, right? The trailer, the preview, the teaser, whatever you want to call it, okay? But please notice that even though this is a little bit rough, again, if I gave you the algorithm, you should be able to implement this because it's not using any feature of the Java language that we didn't cover, right? There's nothing mysterious in that. It's just very clever, Well, don't worry, guys. You are working your way to be that clever. After a data structure, this is pretty much where you're going to be at, okay? But in practice, once you graduate and you have done that, maybe with one, two, three programming language, and people have been hammering down your head, inside your head, recursion, binary search, and all those sorting algorithm, you are working on a project, you need to sort something. You're not going to rewrite it by hand because you take a chance that you're going to mess it up. No matter how good a programmer you are, there's always a chance we're going to mess up, right? So instead, import java.util.arrays. Let's go check the bag of utilities for arrays. And we have this arrays.sort method. Same deal then for the binary search a few slides ago. The arrays.sort method is just there to take an array, sort it for you. So by default, it's sort in ascendant order, okay? If I remember correctly, there's a way to tell it to do the other way around, but it's kind of skipping my mind right now. And just like binary search, it works on arrays of primitive data type. So you can sort your arrays of int, double, char, short, long, and float, no problem. Just pass them to that method, and it's going to sort them for you. It doesn't return anything because watch out, it modifies the array, right? So if you have an array of raw data and you pass it to sort, it's modified. It's been like shuffled around so that everything is in order. So you lost your original order. If you want to preserve your original order, you need to make a copy of the array. What kind of copy do you need to make? A shallow copy or a deep copy? Deep, exactly. If you make a shallow copy, all you did is I have an array, I have a reference variable to an array. Here's another reference variable to the same array. Here, sort this array, please. And you're going to sort that array, which I'm referencing with the other variable. That's not going to help me. Okay, what I want to do is I have a reference variable to that array. I want to allocate another array. Tables are my arrays in the classroom. I guess you noticed that by now. And I'm going to have another reference variable pointing to that array, which I'm going to pass to the method. The method is going to sort that array. My original array is left unscathed. Okay? So, yes, everything is kind of falling together. Last thing, and we are done with module 9 completely this time. No shortcut taken at the end. We've seen that already. Arrays.toString. So it should be just a reminder. This is actually this is something that we use a lot when we want to debug, when we want to display, the content of an array without firing it up the debugger. It's going to actually take any of those arrays of primitive data types, okay, and it's going to allow us to visualize them. So it's going to turn the array into a string. The array is still untouched, okay, safe, but it's going to return to whoever called that method a string. For example, here I want to display it with println, and that string is going to show open square bracket, and then each element in the array separated by comma. So I'm just putting this as a reminder here. We used it already 1 or 2 times, okay, but that's not enough, for people to be generally familiar and comfortable with it. But that's really practical when we are trying to figure out what's happening in an array during runtime. Okay? All right. We have a few minutes left, but it's not enough to really get started with module 10. So I'm going to stop here, but I'm not running anywhere. So if you have questions, please feel free to hang around. And we are almost done. One more session on module 10, and we'll be done with the content for the semester. All right, thank you. Hold on, 1 second.
Oh, all right.
Let me see. That's okay. All right, go for it.
It is actually a quick question.
Yeah.
The IE this Friday is on arrays because I know the last one was on strings.
So what's the number of the array? Remind me. I9. Yeah. So yes, arrays included.
Okay.
But what we cover, like if you notice, what we covered today was kind of like the harder stuff, the stuff that's kind of like completely at the end of this course, beginning of the next ones, right? So I'm not going to expect that kind of stuff, in the IE. But yeah, everything else in module 9 definitely. Make sense?